Hello everybody, welcome into another lesson. So today we're going to solve systems of equations, and particularly two variable systems of equations using a method called Cramer's rule. So here you have, of course, the two variable system of equations with an x and y variable. Well, that x sub 1 and y sub 1 equal some coefficient of x and y on the equation, and of course a is what the equation's equal to, and then likewise with x sub 2 and y sub 2 equal to b. It's the same deal with those. Well, Cramer's rule states that what we have to do is first find the value of our coefficient matrix. So to find the determinant of your coefficient matrix, you'll just take the coefficients of your x1 and your y1 and your x2 and your y2 variables. You'll find the determinant of that, okay? Once you've done that, the next thing you need to do, you're going to find what's called d sub x, the determinant which is d sub x. What that is you're going to take a determinant, keep your y values the same, but since you're trying to find d sub x, you're going to replace the values of the two x variables down the first column with what that equation's equal to. So you'll take your a and b from the right hand side and put those in where the value of the x coefficients were. You can think of it as whatever variable you're trying to find, that's the column you need to replace with what those equations are equal to. So you'll evaluate that determinant, and then to get the overall value of x for the system, you'll take that d sub x over your d, and that's the determinant, which is d sub x over the value of the determinant d, your coefficient matrix, and the d sub x determinant divided by d will give you the value of x. And then we can do the same with y. D sub y, you leave your x column alone this time, but your y coefficients you'll replace with the a and b that those equations are equal to. So then y equals d sub y over your d. So let's get started on some examples here. So what do we got up to bat first? So we have 2x plus y is equal to 3. Then we have 5x plus 6y is equal to 4. Alright, so we have the system 2x plus y equals 3, 5x plus 6y equals 4. So first thing you want to do is find your d, which is simply the determinant of your coefficient matrix. So don't worry about what's to the right of the equal sign yet, but you have two equations, so you have two rows in this determinant. You'll get a 2 by 2 determinant. So to find that, you'll put in the 2 for the x, the 1 for the y, and then you'll put in the 5 for the x, and the 6 for the y. So that determinant, of course, you take the 2 times 6, which is 12, minus your 1 times 5, so that'd be minus 5. That would give you the value of your coefficient determinant to be 7. So now we found d to be 7. Okay, now that we found that, let's find the d sub x. So we want to find x. That means we need to replace the coefficients in the x column with what these two equations are equal to. So for the first one in the x column, you'll replace it with 3. For the second one in the x column, you'll replace it with 4. But you'll keep your y coefficients the same, the 1 and the 6. So I took that 3 and 4, slid it into the x columns, and I kept my y coefficients the same. So of course this determinant would be 3 times 6, which is 18, minus 1 times 4, so that'd be minus 4. Well, the d sub x determinant is 14. All right, now we can find x. So x equals the d sub x over the d. Well, d sub x has a value of 14. The d has a value of 7, so 14 divided by 7 is 2. So the x-coordinate of the ordered pair for this would be 2. Now let's find d sub y. So since we are seeking to find the y-coordinate, we'll leave the x coefficients alone. We'll have 2 and 5 still in our x column. But that 1 and 6 in the y column will get replaced with that 3 and that 4, since we're trying to find y. So now let's just find the determinant. 2 times 4 is what? That's 8, minus 3 times 5, which is minus 15. 8 minus 5 is negative 7. So now we got d sub y. So to find y, we take that d sub y over the d. Well, d sub y actually has a value of negative 7, and then the d just has a value of positive 7, which would give you a y value of negative 1. So now we know the ordered pair that's a solution to the system. It's going to be 2, negative 1. And for a 2 by 2 system, Cramer's rule is kind of nice, because you don't have to do a whole bunch of row operations like we did before with matrices. You can just use simple 2 by 2 determinants and do it that way, as opposed to a whole bunch of row operations. I got plenty more examples. Okay, what's next? The next system, I have 7x minus 5y is equal to 11. So 7x minus 5y equals 11. And wow, 3x plus 10y equals negative 56. So that's big jump in numbers. So here's our system. First, let's set up our coefficient determinant, which would just be that d. That's going to equal, of course, your coefficient matrix. So you'll have 7, negative 5, 3, and 10. So there's your coefficient determinant. So 7 times 10 is going to be 70. Minus negative 5 times 3, that'd turn into plus 15, which would end up giving you the d value of 85. So that's your coefficient determinant, which is 85. Now let's seek to solve for x. So let's take d sub x. So you're going to start out by taking your x coefficients, replace the first one with the 11, the second one with negative 56, then leave your y coefficients alone. Alright, so what is 11 times 10? Well, that's 110. Now we're going to have minus 5, which turns into plus 5 times negative 56. So let's figure out what that is. That'd be minus 280. 110 minus 280 is going to be negative 170. So we got the value of dx now being negative 170. And then just to find x, we'll take that dx and divide it by our d. So dx was negative 170. Divided by our d value of 85, giving you an x value of negative 2. So x equals negative 2. Now let's find our y. So let's take d sub y. Well, this time we're trying to find y, so leave your x coefficients alone in that determinant. But your y coefficients, you're going to replace the first y with 11, the second y with negative 56. Alright, so 7 times negative 56, we have to get to what that is. That'd be negative 392. So that's negative 392 minus 11 times 3. That's another minus 33, which would equal negative 425. So d sub y is negative 425. Now let's go ahead and find y, which is going to be that d sub y divided by that d. D sub y has a value of negative 425, and then the d itself has a value of 85, which should give us a result here for y. So let me figure out what the heck that is. That would end up being negative 5. So y ends up being negative 5. So now that you know x and y, you have the ordered pair that's the solution. And the ordered pair that would be the solution to this system would be negative 2, negative 5. Alright, now when we get to 3 by 3 systems in the next lesson, Cramer's rule, it's still sort of nice, but it can take a little longer because then you're dealing with 3 by 3 determinants and all that. But it's the same process. Okay, next system, 9x plus 2y is equal to 7. Then we have 4x minus 3y is going to be equal to 42. Alright, so here's our system. 9x plus 2y equals 7. 4x minus 3y equals 42. So let's go ahead and set up our normal d determinant, which is our coefficient determinant. That will be your coefficient of 9, and then your 2, and then your 4, and then that negative 3. Alright, so 9 times negative 3 equals negative 27. Minus 2 times 4, that'd be minus 8, which would give you a value of d being negative 35. So therefore, d equals negative 35. Now that we know the coefficient determinant, let's find d sub x. So to find d sub x, you're going to take the coefficients in your x column, replace them with 7 and 42, but keep your y coefficients the same, the 2 and negative 3. Well, what is 7 times negative 3? That's going to be negative 21. Minus 2 times 42, that'd be minus 84. So negative 21 minus 84 is negative 105. Okay, so we know d sub x now. Let's proceed to find x, which of course would be that d sub x over d. Well, d sub x is negative 105 over your d, which is negative 35, which would actually end up turning out to be positive 3. So you have an x value of 3. Now let's find y. Start out by doing d sub y. So d sub y, this time you're going to leave your x coefficients alone. You'll keep the 9 and 4, but you're going to replace your y coefficients with that 7 and 42. Alright, so now what the heck is 9 times 42? Let's figure that out. 378 minus 7 times 4, that'd be minus 28. So 378 minus 28, that's going to be 350. So now we have a value of d sub y being 350. So to find y, you'll take your d sub y over your d, which we know d sub y was 350. We'll divide that by our d, which is negative 35, which would give you a y value of negative 10. So the ordered pair that's the solution to this system would be 3, negative 10. that would be your solution to this system, 3, -10. All right. I have about 6 more. Alright, so we have x plus 7y is equal to -3. Then we have 3x minus 5y is equal to 17. So this system here, x plus 7y equals -3, and 3x minus 5y equals 17. So let's go ahead and find our d determinant, which would just be the coefficient determinant. So your x coefficient of 1, your y coefficient of 7, and then you have your x coefficient of 3, your y coefficient of -5. Alright, so 1 times -5, that's going to be equal to -5, minus 7 times 3, so that'd be -21. So your d is equal to -26. So we found d to be -26. Now in order to solve for x, we first need to find d sub x. So you're going to take your x coefficients, replace them with the -3 and 17, but keep your y coefficients the same, the 7 and the -5. Alright, so -3 times -5 turns out to be positive 15. Minus 7 times 17. Let's figure out what 7 times 17 is. That'd be 119. So 15 minus 119. That should end up being -104. So d sub x is -104, so x will equal that d sub x over the d. D sub x was -104 all over the d, which is -26, which would give you an x value of 4. So x equals 4. Now in order to find y, we need to do the d sub y determinant. So to find d sub y, this time keep your x coefficients the same, the 1 and the 3, but replace your y coefficients with that -3 and 17. Alright, so what is 1 times 17? Well, that's just going to be 17 minus -3 turns into +3 times 3, so that'd be +9. 17 plus 9 equals 26. So now we can find y by taking that d sub y over the d, which d sub y was positive 26, divided by the d, which was -26. So that would give you a y value of -1. So the ordered pair that ends up being your solution is going to be 4, -1. So 4, -1 would be the solution to this system. I have about 5 more. Alright. We have -x minus 12y is equal to 44. Then we have 12x minus 15y is going to be equal to -51. So some big numbers to work with. So this system, -x minus 12y equals 44, 12x minus 15y equals -51. So let's go ahead and set up our d determinant, which would just be our coefficient determinant. So take that -1 on the x, then that -12 on the y, and then take that 12 on the x, and that negative 15 on the y. Alright, so what is negative 1 times negative 15? Well, that's simply going to be positive 15. Then we have negative 12, which would be 12 times 12. That's 144. So 15 plus 144 is going to be equal to 159. So the value of D in this case is 159. Now, we know our coefficient determinant. Let's find x by first finding d sub x. So to find d sub x, take your x coefficients, replace them with that 44 and the negative 51, but keep your y coefficients the same of negative 12 and negative 15. Okay, so 44 times negative 15, we first got to ask ourselves that. That would be negative 660. Alright, then minus 12 is plus 12 times negative 51. So this turns into 12 times negative 51. That'd be minus 612. Which would end up equaling negative 1272. So d sub x is equal to negative 1272. Now we can directly find x by taking that d sub x and dividing it by d. Well, d sub x was negative 1272 all over your d, which was 159. So let's figure out what the heck that is. Yep, that would end up being negative 8. So you get an x value of negative 8. So we found x, now we need to deal with finding y. So first we have to find d sub y. So to d sub y, we keep our x coefficients the same this time, which would be negative 1 and then 12. And then we're going to replace the y coefficients with that 44 and the negative 51. Alright, so negative 1 times negative 51 turns into positive 51. Minus 44 times 12, we're definitely going to get a negative number. So let's figure out what the heck 44 times 12 is. Alright, 528, so that'd be 51 minus 528. So now let's figure out what the heck is 51 minus 528. Turns into negative 477. So d sub y equals negative 477. So to find y, you'll take that d sub y and divide it by your d. Well, d sub y is negative 477 divided by your d of 159, which I want to say that's going to end up being negative 3, but let me just confirm. Yep, it sure is. So y would have a value of negative 3. So now we know both x and y, so our ordered pair that's the solution would be at negative 8, negative 3. That is the ordered pair that's the solution to the system. Negative 8, negative 3. And I should have about 4 more left. Alright, what do we got here? So we have 4x minus 3y is equal to 18. Then we have 8x minus 7y is equal to 34. So here's the next system. 4x minus 3y equals 18. 8x minus 7y equals 34. So let's set up our normal coefficient determinant of D. So D, you're going to take the coefficient determinant, so take your 4, your negative 3, your 8, and then your negative 7. So there's your coefficient determinant of D. All right, 4 times negative 7, that's negative 28. Minus negative 3 turns into plus 3 times 8, that'd be plus 24, giving you the value of D to just be negative 4. So our coefficient determinant is negative 4. Now in order to find x, let's take our D sub x. So for D sub x, you'll replace your x coefficients with the 18 and 34. You'll keep your y coefficients the same of that negative 3 and negative 7. All right. So let's figure out 18 times negative 7 first. That'd be negative 126. Minus negative 3 turns into plus 3 times 34. So 3 times 34, just as I thought, 102. So that'd be plus 102. So negative 126 plus 102 is going to end up equaling negative 24. So now to find x, we just take our D sub x, divide that by D. So D sub x was determined to be negative 24. And then D is negative 4, so negative 24 divided by negative 4 turns into positive 6. So x equals 6. Now let's figure out D sub y in order to get y. So D sub y, you'll keep your x coefficients the same, so you'll have 4 and 8. But for your y coefficients, you'll replace those with the 18 and 34. All right. So let's figure out 4 times 34 first. That would be 136. So we have 136 minus 18 times 8. So what is 18 times 8? That'd be minus 144. So 136 minus 144, that's going to end up simply being negative 8. So D sub y is negative 8. Now to find y, you're just going to take that D sub y over that D, in which D sub y is negative 8. And then D is going to be negative 4. So negative 8 divided by negative 4 is positive 2. So you got the ordered pair that's the solution would be 6, 2. So 6, 2 is the ordered pair that's the solution to this system. And I have about 3 more left, then we're done. All right. We have 4x minus 5y is equal to 13. Then we have 2x minus 7y is equal to 24. So in this system, 4x minus 5y equals 13, 2x minus 7y equals 24. So let's set up our coefficient determinant, which is D. That's equal to the determinant of, take your x coefficient of 4, your y coefficient of negative 5, then your x coefficient of 2, your y coefficient of negative 7. All right, so what is 4 times negative 7? That's just going to be negative 28. Then negative 5 turns into plus 5 times 2. That'd be plus 10. Negative 28 plus 10 is negative 18. So the value of your coefficient determinant is negative 18. That's the D. Now to find for x, we need to, of course, get the value of d sub x. So to do d sub x, replace your x coefficients with that 13 and 24. Then keep your y coefficients the same, the negative 5 and the negative 7. All right, so what is 13 times negative 7? That'd be negative 91 minus negative 5, which turns into plus 5 times 24. That'd be plus 120, which would give you a value of 29. So d sub x is going to end up being 29. Now, what we got to do to find x, just put in the d sub x over your d. So d sub x was determined to be 29. Then the d is negative 18. This really doesn't reduce any further, so your x value would be negative 29/18. So yes, you have a fractional answer, and sometimes you're going to have that, but x is negative 29/18. Now, what about y? So let's do d sub y. That would equal, of course, leave your x coefficients alone this time, the 4 and 2, but replace your y coefficients with 13 and 24. So what's 4 times 24? Well, that's going to be 96. Minus 13 times 2, well, that would be minus 26. 96 minus 26 is 70. Now we know d sub y, we can just find y by taking that d sub y and dividing it by d. Well, d sub y ended up being 70, and then the d is negative 18. Both of these have a common factor of 2, and the negative sign will come to the numerator. This would end up being negative 35/9 for your y. So the ordered pair that's the solution is going to be negative 29/18 and then negative 35/9. So yes, you can get fractional answers still, but negative 29/18, negative 35/9 would be the ordered pair that's the solution to this system of equations. Okay. Got 2 more examples here. Now, let's see what's next. 8x minus 9y equals 32. And then negative 5x plus 7y is going to equal 40. Alright, so in this system, 8x minus 9y equals 32, negative 5x plus 7y equals 40. So let's set up our coefficient determinant of d. So take that 8 on the x, the negative 9 on the y, that negative 5 on the x, and then that 7 on the y. Alright, so what's 8 times 7? That's going to be 56. Minus negative 9 turns into plus 9 times negative 5, so that'd be minus 45. 56 minus 45 equals 11. So the value of your coefficient determinant is 11. Alright, well now that we know that, let's solve for x by first finding d sub x. So to find d sub x, take those x coefficients, replace them with the 32 and the 40. Then keep your y coefficients the same, the -9 and the 7. Alright, so let's figure out what in the heck is 32 times 7. That I don't know off the top of my head. 224, alright. Minus -9 turns into +9 times 40. That would be plus 360. So what is 224 plus 360? Well, that would end up being 584. So d sub x is 584. Let's go ahead and just solve for x by taking that d sub x and dividing it by d, which the value of d sub x was 584, divided by that d of 11, which, let's see what 584 divided by 11 is. I haven't the foggiest clue, but actually I think I do, but it doesn't reduce any further. So you're just going to have a real hideous result of 584 over 11. That just doesn't reduce any further. Alright, now let's solve for y by finding d sub y. So to find d sub y, you'll keep your x coefficients the same, the 8 and the -5, but you'll replace your y coefficients with that 32 and 40. So what's 8 times 40? Well, that's simply going to be 320. Now you'll have minus 32 times -5. That would turn into 32 times 5. Which would be plus 160. $320 plus 160 is 480. Alright, so we have 480 for d sub y. Now we can just find y by taking that d sub y and dividing it by our d, which d sub y was 480, and then just d is 11. And I don't think it reduces further, but I have been wrong before, so let's just verify that for sure. 480 divided by 11, it does not reduce any further. So we at least now have our two ordered pairs. X would end up being 584 over 11. Y is 480 over 11. So the ordered pairs that would be the ordered pair that's a solution to this system is going to be 584 elevenths, 480 elevenths. And I got just one more example here. I would rather we get answers like that with determinants than we did doing matrix operations. Doing normal matrix operations, that would be some hideous work to do. Determinants at least kind of simplify it a bit. One more. We have 3x plus 10y is equal to 50. Then we have 12x plus 15y is going to be equal to 64. Alright, so this system, 3x plus 10y equals 50, 12x plus 15y equals 64. So let's go ahead here, set up our coefficient determinant of d, which would take that 3 on the x, that 10 on the y, then take your 12 on the x, and then the 15 on the y. Alright, so what is 3 times 15? That's going to be 45. Minus 10 times 12, that'd be minus 120. So 45 minus 120 is negative 75. So the value of d is going to be negative 75. Now to solve for x, let's find d sub x. So to find d sub x, take your x coefficients, replace those with that 50 and that 64, and then keep your y coefficients the same, the 10 and the 15. Alright, so what is 50 times 15? That's going to be 750 minus 10 times 64, that'd be minus 640. 750 minus 640 is 110. So d sub x is 110. So to find x, you're going to take that value of d sub x, which is, well, let's write this out first. D sub x over d, which equals 110 over negative 75. I know it reduces further. They both at least have a common factor of 5. Yep, so it'll end up being negative 22/15. So x would have a value of negative 22/15. Now let's solve for y. So find d sub y first. For d sub y, you'll leave your x coefficients alone, keep the 3 and the 12, but replace your y coefficients with 50 and 64. Alright, so what the heck is 3 times 64? I have a rough idea, but I just want to be sure. I think 192, but let's be sure. Yes, it is 192. So you'll have 192 minus 50 times 12, well that'd be minus 600. Which would end up giving you minus 408. So d sub y is negative 408. So let's go ahead here and figure out y, which would just be the d sub y over d, which d sub y was negative 408 over your d of negative 75. I want to say 408 is reducible by 3, but let's just be sure on that. I know the negatives will turn this positive, but yes, so you'll have 136 over 25. So y ends up having a value of 136 over 25. So the ordered pair that's going to be your solution would be at negative 22/15, then 136 25ths. And that would be the ordered pair that's the solution to this system of equations. So that's it for this lesson. Next lesson we will do Cramer's rule for 3-variable systems of equations. It's going to run similar to this, only we're going to have 3x3 determinants, which as we know are not quite as nice to work with. So I hope everybody has a great day. Take care.